Welcome to the DIY Honda Garage channel. The DTC P0158 pertains to a malfunction in the front secondary heated oxygen sensor, HO2S, circuit specifically for Bank 2, Sensor 2. This sensor plays a crucial role in detecting the oxygen content of exhaust gases located downstream of the front warm-up three-way catalytic converter. The sensor assists the powertrain control module, PCM, in controlling the air-fuel ratio to optimize engine performance and efficiency. When the PCM receives excessively high output voltage readings from this sensor, it generates the P0158 code. It indicates a potential issue that could impair exhaust gas management, leading to increased emissions or fuel inefficiencies. Symptoms of failing components can escalate quickly, so timely diagnostics and repairs are vital to ensure compliance with emission standards and maintain engine performance. In summary, DTC P0158 represents a central issue concerning the front secondary heated oxygen sensor circuit's high voltage output. Identifying its causes, symptoms, and effective troubleshooting steps is key to resolving the malfunction promptly. Each phase of diagnostic work, from initial identification to final verification post-repair, is structured to ensure a thorough approach to sensor functionality. Understanding the relationship between the secondary HO2S and the vehicle's performance empowers technicians to tackle problems proactively, thereby enhancing engine efficiency and compliance with environmental standards. Furthermore, adopting preventive maintenance practices emphasizes the importance of vigilance in sensor health, ultimately benefiting both the driver and the environment. Timely interventions and careful monitoring are essential for a smooth and efficient running vehicle. The secondary heated oxygen sensor, referenced as Bank 2, Sensor 2, is primarily responsible for monitoring the oxygen levels in the exhaust gases after they pass through the catalytic converter. Located after the front warm-up three-way catalytic converter, its real-time readings are crucial for the PCM to determine whether the engine is operating at stoichiometric levels. The sensor works alongside a primary air-fuel ratio sensor located upstream, enabling effective feedback loop control for optimal combustion. When the sensor's output voltage exceeds the predefined threshold, the PCM logs the DTC P0158, signaling a high voltage issue within the circuit. This scenario calls for an immediate inspection to identify any wiring issues, sensor failures, or potential short circuits leading to erroneous voltage readings. Addressing such faults is crucial for ensuring not only performance consistency, but also emission compliance. The occurrence of DTC P0158 can usually be traced back to specific causes. First, a circuit failure may arise due to damaged wiring or connectors affecting the signal transmission from the sensor to the PCM. Any breaks or shorts in the wiring can significantly alter the voltage levels being reported. Secondly, the sensor might output a rich condition that appears stuck, where it's continually providing high voltage feedback irrespective of actual oxygen levels in the exhaust. This anomaly can create false impressions of excessive fuel mixtures, disturbing the air-fuel ratio corrections enforced by the PCM. Understanding these potential causes arm technicians with the knowledge to conduct more focused diagnostics during troubleshooting, ultimately leading to quicker repairs and improved vehicle function. Drivers may observe several symptoms associated with DTC P0158. The most immediate and noticeable symptom is likely the illumination of the check engine light, MIL, indicating a malfunction that needs immediate attention. Additionally, the vehicle might exhibit reduced fuel efficiency as the PCM struggles to maintain an optimal air-fuel mix due to the inaccurate sensor readings. This inefficiency not only results in potentially higher fuel costs, but can also produce increased emissions, which may violate environmental regulations. If left unchecked, this can lead to further complications, such as engine misfires or rough idling, affecting the overall driving experience. Understanding these symptoms helps prioritize timely repairs to restore performance and compliance with emission standards. The first step in diagnosing DTC P0158 involves starting the engine and allowing it to idle until the radiator fan activates. This procedure may take several minutes, ensuring that the engine reaches its normal operating temperature. The activation of the radiator fan indicates a sufficient warm-up period, which is essential for accurate readings from temperature-sensitive components, like the secondary heated oxygen sensor. Observing this initial phase is crucial, as it sets the stage for proper sensor function and eventual diagnostic success. A full understanding of engine temperature can aid the technician in determining if the sensor readings are viable or if issues need addressing immediately. Once the engine is idling and the radiator fan has activated, the next step involves maintaining the idle for a minimum of 5 seconds. During this period, it is crucial for the technician to monitor the secondary heated oxygen sensor's activity closely. If the sensor is operating normally, it should reflect voltage readings that vary according to the exhaust content. Any indication of high voltage readings, such as exceeding the 1.27 V threshold, could imply a fault that merits further investigation. By meticulously tracking the sensor's behavior during this phase, experienced technicians can discern whether the problem resides within the sensor, circuit, or even the PCM itself. Following the idle phase, the technician must drive the vehicle at a steady engine speed between 1,500 to 3,000 RPM for not less than 5 seconds. This acceleration allows the PCM to engage in feedback monitoring under real-world operating conditions, where the secondary heated oxygen sensor can deliver readings reflective of the exhaust characteristics. It's crucial that this acceleration is performed smoothly to avoid erratic data, thereby ensuring accurate monitoring outcomes. The specified RPM range is particularly effective in checking the sensor's functionality, since the engine will be under load, making any faults more pronounced. After this driving phase, a thorough assessment of the sensor readings can reveal whether the DTC persists or if corrective actions can be applied. Following the repairs, it is vital to carry out a final verification of DTC P0158. Start by clearing any stored diagnostic trouble codes, DTCs, from the Powertrain Control Module, PCM. This can be executed using an onboard diagnostics, OBD, scan tool that facilitates the clear command. Post-clearance, conducting a test drive under the same conditions that initially triggered the DTC is imperative. This step aims to reevaluate the secondary heated oxygen sensor and observe if the previously problematic conditions return. If the check engine light remains off and no new DTCs are recorded, it indicates a successful repair. Careful verification ensures long-term reliability and compliance with emission standards. In maintaining the health of the oxygen sensor circuitry, regular inspections are a vital preventive measure. Technicians should prioritize routine checks of the secondary heated oxygen sensor, focusing on wire integrity, connector cleanliness, and electrical continuity. These inspections can help catch any wear or damage before they escalate into significant malfunctions like P0158. Furthermore, ensuring that all electrical connections remain secure and free from corrosion preserves the overall functionality of the PCM and sensor systems. Regular maintenance should also include engine checks for air and fuel mixtures to optimize combustion efficiency. A proactive approach not only minimizes the risk of future DTCs, but also enhances vehicle performance and longevity. Please like and subscribe to the channel. See you next time.